This is the first differentiation test. First differentiation test, okay? Now, f of x. F of x is a function, okay, and it wants me to differentiate once. The rule is, any number that comes in front of x, when you differentiate it, the only thing that's going to be left is that number. So we differentiate 5x, you get 5. Differentiate 7x, you get 7. You differentiate 1x, you got to get 1. Now, see this 1 over x squared? You have an option with 1 over x squared. You could do u and v. You could do the quotient rule if you wanted. But that's not the way I did anything in exercise 1. In exercise 1, I always did the rules of indices. Okay? And the rules of indices, I'd get x to the minus 2. And when I differentiate x to the minus 2, I do what's called the chain rule there. I bring the minus 2 to the front. I leave the x where it is, and I take 1 away from the power. 2x minus 3 is the answer to that. Some of you rewrote it as 1 over 2 divided by x3, which is also acceptable. Is there any questions thus far?
So that's all it was now. That's the answer.
Yeah, that's the answer. Okay. Now, the next one, okay, is f of x. And what you're going to see here is I'm going to do a couple of rearrangements. The first one is 2 over x to the half. Bring the x to the half to the top. It's going to be 2x to the minus a half. Notice I haven't differentiated yet. I'm just giving it a makeover. Okay? This one here is going to be minus x to the minus 4 and plus 5. Now, and only now, am I differentiating. There's no differentiating done yet. Just me rearranging it. Now, f of x, like last time, you bring the power to the front and multiply it by the number that's already there. 2 times minus a half? Minus 1. Take 1 away from the power? 2. Okay, minus 4 goes to the front and multiplies by minus 1. Plus 4, x to the minus 5. If you differentiate any number on its own, it will turn to 0 every time. Differentiate a million, turns to a million. Differentiate k, where k represents a number, that also turns to 0. So therefore the 5 turns to 0. Not there. And that's our answer. Okay? That's question 1 done. 5 marks each. Okay? Question 2. Right. S is this, and then it wants the SDT. Okay? And it wants the SDT, which means it wants the first derivative. Okay? So, first derivative is going to be basically differentiate 3t squared. What happens when you differentiate 3t squared? 6t plus 5. Okay? And get it when t equals 2. 6 times 2 plus 5? 17. Okay? Yeah. Alright. Part 2 then, okay? F of x ends up to be equal to x to the power of a half plus 3x. What it wants me to do is differentiate once and replace x equals 4 into it. So differentiate once, bring the half to the front. Half x to the power of minus a half plus 3. When you differentiate 3x, it turns to 3. Okay? Now and only now do we put in the number 4, because we want f dash 4. Okay, so f dash 4 means replace x with 4. So we're going to get a half, 4 to the power of minus a half, plus 3. And what that's going to turn out to be is 3 1/4 when you use your calculator. Or, what's the other one, 13 over? 4. Okay. Any questions thus far?
Just hold it there for a second.
Yeah. Nice. Now, I can do here is I have 2 different rules I can do here. I can do a quotient rule where I can change it to this. So I can do this one here. Now, I haven't differentiated yet. What I just did was I changed it to the power of a half. Okay? Now I have an option. I could do a quotient rule where u equals 1 and phi equals 2x squared minus 4x all to the power of a half. I can do that if I want. Okay? And that's okay to do that. And then you could write down the quotient rule, which is the y dx equals phi du dx minus u the v dx all over phi squared. But the way I would have taught you guys how to do this would have been using the chain rule. Okay? And what I would have done is I would have rearranged the full thing to a negative power. Okay, so remember, it's the same thing, except it has a negative power. Now, here's the part where everybody tends to get just a slightly bit confused on, okay? What happens is, if I ask you to differentiate x to the power of minus a half, what you guys will tell me is you move minus a half to the front, you leave x where it is, and you take 1 away from the power. This one behaves exactly the same with one addition, okay? So x represents the box. Power in front of box, take 1 away from power. In this case, this one here is the box. So we're going to do exactly the same thing. Minus a half, the box stays the same. 2x squared minus 4x to the power of, what is it? Minus 3 over 2. Now, here's the missing part. When you differentiate this, you also differentiate what's in the box. Now, the reason why it doesn't turn up for this one is when you differentiate x, what do you get? 1. That's why it doesn't make a difference, and that's why we don't do it. But in this case, when you differentiate what's in the box, it's going to be 4x minus 4. Okay? So we're going to get 4x minus 4. Now, some of you want to pick up full marks for the following reasons, okay? You wouldn't have multiplied it by minus, okay? So you have to multiply minus 1 by 4x minus 4 and then divide by 2. Let's divide by 2 right away. And now we have to multiply it by minus 1. That's going to get me minus 2x plus 2. Now, I've made a mistake. Can anybody tell me what the mistake is? This point in time, I'm not multiplying. I have to put these in brackets because it's all of this multiplied by all of this. Okay? So an example would be if I said 3 plus 5 multiplied by 10. We all know the answer is 80, correct? But if I get rid of the brackets, look what happens. It'll no longer be 80.
53.
It'll be 53. And that's what happened to a couple of people in the test without putting on the brackets, okay? So you got to make sure that your brackets are intact properly. Okay? Next part is we're going to do the product rule. Okay? Yeah.
Did you have to write it down in the last bit?
Yes.
No. Did you have to could you just leave it?
No, you have to do this.
You have to do it.
Yeah.
How much marks did you take off here?
About 2 marks at minimum attempt.
You got minus 2x minus 2 instead of minus 2x plus 2.
Shh. Now that that's done, okay, look at this, okay? What we have here is the product rule, okay? Now, some of you might ask me, how do I know it's a product rule? I'm going to rewrite this question like this, okay? Now, if I rewrote this question like this, it's obviously not the same number. Now, if I differentiate this one, okay? And this is not what's the question in the test is. If I differentiate this one, the answer is going to be 6x. And then I do a very basic chain rule for the second one. It'll be 2 times 2x plus 3. 2 times what's in the box. Take 1 away from the power. Differentiate what's in the box. So, times 2. And this one here would be 6x plus, that's going to be 4. So that's going to be 8x plus 12. And that would be 14x plus 12. Now notice the difference between the question I just did here and the question that you had in your test. In your test it's multiply and not plus. Therefore done in 2 completely different ways. When you're multiplying 2 different variables by each other, now what I mean by variable is they both have x in it. You pick a space to split it in half. You then go u equals 3x squared. V equals 2x plus 3 squared. Du dx ends up to be 6x. Dv dx ends up to be bring 2 to the front, take 1 away from the power, differentiate what's in the box, and we get it's like earlier, it's 4x 8x plus 12, isn't it? Okay, now once you have that, you then go for your product rule, okay? Okay guys, so what you do get is this, okay? The y dx ends up to be u dv dx plus phi du dx. Now, what's going to happen here is you got to replace each one with its what its counterpart is. So u is 3x squared. Now a lot of you took it down wrong. You didn't put the x squared in. The next one is the v dx, which is 8x plus 12. Okay. After that, it's going to be plus phi, which is, I'm going to square out phi. Is alright if I square out phi right now? I'm just going to square it out because it is 2x plus 3 squared, so I'm going to square that out. And I'm going to get 4x squared plus 12x plus 9. That's when you square the brackets out. And once I've done that, I have to multiply that by 6x. Now what we're going to have here is 24x cubed, 36x squared, plus 24x cubed, plus 72x, plus 72x squared, plus 54x. Add them together, we get 48x cubed, 108x squared, and 54x. You could factorize that if you wanted, but that's a perfectly good answer for that one. Any questions thus far? Okay. Now, find the derivatives of the following functions, okay? Now, these ones here.
So what was the last? 48x squared cubed plus 108x.
Squared plus 54x. Question there, yeah?
Yeah, how do you know when...
Some people are wondering, how do I know when I can square stuff out? Okay, so an example would be something like this. If you have basic BOMDAS, okay, if I have 3 multiplied by 2, I can multiply that out right away and say it's 6. However, if I had 3 multiplied by 2 to the power of 5, it's blocked because I'd have to figure out what 2 to the power of 5 is. And 2 to the power of 5 in this case would be 32. And then only when I do this part here am I then free to multiply out. Now, that'll bring me back to fraction, that'll bring me back to algebra now, okay? Now look guys, look at this. In this case, right, a similar type question. 3 times, let's say, x plus 2 to the power 1. Because it's the power 1, it's free to multiply. So 3x plus 6. But in the case where it's the power of, I don't know, 6, I'd have to multiply out x plus 2, x plus 2, x plus 2, by x plus 2, by x plus 2, by x plus 2. And you're not going to do that. It's an absolutely massive number. So basically, long story short, when it has a power other than 1, sometimes you might do it when it's squared. Depends how high the power is going up to. Usually when you have 3 and 4, it's not going to happen. Okay?
But in differentiation, is there some situations where you cannot, you're not allowed to square?
Well, if you have the power of 5, you're not going to square that out.
But that's that's like logically you wouldn't do it.
Yeah. And another one, alright, so let's say for example we had something like this, right? X squared plus 3x, okay? And then we had 4 multiplied by x to the power 3 plus 2x to the power 6. When I multiply that out, it's going to be massive powers of x, so it's not worth doing. If I had it to the power of 1, it's probably worth doing out. To the power of 2, I'm going to have x to the power of 6. It's not going to cancel anything to its sides. You're not going to be able to add them together, so then there's no point.
Okay.
But if I was to completely flip this on its head and say all of a sudden, oh wait a minute, now it's just x plus 2 to the power of 2, then it'd be worth doing because I'm going to get x squareds and I can add x squareds to x squareds.
Okay.
So it depends on how high your powers are.
Right.
Okay? Now, on to number cos 3x here, okay? Y equals cos 3x. Now, cos 3x, we're going to have to differentiate, okay? Now, the rule is for trigonometry, the brackets or the angle is always protected. Do you understand? It never changes. The first thing you know is that the 3x is going to go directly down. What does change, however, is the function. Cos changes into sine. Okay, one last thing. You have to differentiate the box. and that will get you 3. What you're not allowed to do, this is an angle, part of sine, it's not a separate number. You cannot say sine 9x, that's not allowed. What you have to say is minus 3 sine 3x. Okay? Now the next one, that's dy dx, by the way. Please remember to write down dy dx when you differentiate. Okay? The next one, which is part 2. Okay? Y equals tan to the power of 3 5x. Now dy dx, I'm going to rewrite this, okay? Actually, just leave it as y for the time being. I'm going to write it as tan 5x to the power of 3. You've got to remember, how does the chain rule work again? Remember we said earlier, the chain rule, the box never changes. Okay? So dy dx, because it has a power, it's protected. Okay? It's not going to go anywhere. So the 3 goes to the front, you take 1 away from the power, and you get tan 5x to the power of 2. Okay? Now here's the tricky part. You also have to differentiate what's in the box. And what's in the box is tan 5x. You look up tan, and what do you find? Secant squared. Okay? You look up and the angle never changes, like in part 1. Now, we do, however, have to differentiate the angle, which is where the extra 5 comes from at the end. So it's going to be secant squared 5x multiplied by 5. Now, Simon, see the squareds?
Yeah.
They're protecting them from being multiplied. Okay? So the only 2 I can multiply by each other is the 3 and the 5. It's 15, okay? And it's going to 15. I can write tan squared 5x if you want. It's the same as tan 5x squared. And that's going to be sec squared 5x. So you can leave it like that.
But how do you...
Yeah.
Why all of a sudden is there like an extra function?
Alright guys, next function is x sine x. Now, it's not being added, which means I can't do both derivatives or differentiate both of them separately, alright? Because they're being multiplied by each other, it's a dead indication of the product rule. I'm going to write down the product rule before I even begin. U dv dx plus phi du dx. And once I've done that, what happens is u equals x, du dx equals 1. Phi equals sine x. That means dv dx equals cos x. Okay? Then once I'm here, all I gotta do is fill it in. U is x, dv dx is cos x, and then v is 1, phi is sine x, and du dx is 1. And the answer is x cos x plus sine x. Okay, any questions on that one? Yes, Connor?
If it's 2 variables, it's product rule.
Okay, last one, okay? Y equals cos x to the power of a half, okay? Now, if automatically, this is something that you were talking about earlier. See the way it's not cos to the power of 1. Because it's not cos to the power of 1, there's going to be an extra function involved, okay? So, what you say is dy dx, you use your chain rule, a half goes to the front. Then take away 1 from cos a half. So it's cos minus a half. Now, the missing part is you got to differentiate. When there is a power involved, whatever is in that box needs to be differentiated. And that turns into minus sine x. Now, we do differentiate the angle, but when I differentiate x, what do I get? 1. So that's why sometimes we leave it out. Okay? So what we're going to get is minus sine x over 2. Because it's a negative power, it can go to the bottom as cos x to the power of a half. And we know that power of a half means square roots. So here's our answer here. Okay. Now,
you have to